Hello. Today we're going to learn a little bit about related rates. To start, we'll do a bit of review. Please pause your video and do problems 1 and 3 of the page 250 quick review and check your answers in the back of the book. Great job! Now we'll do some implicit differentiation. Please follow along in your notes. So we have this equation, and we want to differentiate it. So to differentiate it, we need to use the product rule and the power rule, and we have to differentiate implicitly. So it's going to be now we just want to simplify that. And now you just want to get all the dy dx's on one side by themselves. And now just solve for dy dx. Perfect! So now please pause the video and take a look at the procedure for related rates on pages 246 to 247 in your book. Excellent job! Now we're going to do an example. So here's a fun little story problem. Please take a moment to read over this problem. To start, you want to draw a little picture of the situation. I've already included a compass in mine. We want to start by drawing the police cruiser. Then you want to draw the bad guy car. Now that you've done that, you can clearly see that the picture is going to be a triangle. So now you want to remember that the Pythagorean theorem is a squared plus b squared equals c squared. And since this is calculus, we're going to differentiate it. So use those implicit differentiation skills. Since there are so many 2's, you can cancel all of them out. Oh, Alright, now you want to figure out what all of the numbers in the problem truly mean. So since the police cruiser is 0.8 miles north of the intersection, which is here, you know that the point, well, let's just label this triangle first. A, B, C. So you know that A equals 0.8. And you know that the car is 0.6 miles east of the intersection, so you know that B equals 0.6. To find C, you just have to do the Pythagorean theorem. And now you want to also find dA dt, dB dt, and dC dt. So dA dt would be how fast the police car is moving. Since it's moving at 60 miles per hour, but it's closing the distance between it and the car, it would be negative 60. dB dt is how fast the car is moving away from the police officer. And we don't know what that number is. And dC dt would be how fast the distance is changing between them, which we know is 15. So to solve for C, I'll just break out my trusty calculator. Ah, it's 1. Is that right? So now we know that in our equation, we will be solving for dB dt. So we just want to plug all the numbers in there and come up with an answer. And the answer is 105. But what are the units on this? This is a question that you need to ask yourself. As you ponder that, please try exercise 13 on page 251. Perfect! One more example for today. We're going to find the rate at which the area of this triangle is changing. Remember that the area of a triangle is A equals half times base times height. We can assume that the base and the height are A and B, so it can be written A equals half times A times B. So when we derive this equation, it's dA dt equals half A dB dt. Oh, gosh dang it. Plus half B dA dt. Now you just plug in the numbers that you already have and solve for dA dt, and you are good to go. So please pause the video and try that out. Great job! Now try exercise 11 on page 251. Remembering that the volume of a sphere is 4/3 pi radius cubed, and the surface area is 4 pi r squared. Well, would you look at that? They're derivatives of each other. After trying and checking problem 11, please give problem 1 a shot. This video was brought to you by me, Laurie L.